Welcome to Insight Engine Academy. In this video, we will discuss how can we make chemical equations more informative. We know how to write a balanced chemical equation, right? If I write a balanced chemical equation, let's say example, a reaction of sodium with water. A reaction of sodium with water, we'll take an example. In this example, sodium reacts with water. I write chemical equation, sodium plus water gives rise to sodium hydroxide plus hydrogen, right? This is a skeleton equation, right? We know how to balance this. Since we have and 2 hydrogens left hand side, 3 hydrogens right hand side, how do we balance? We just double the number of reactants, number of molecules of reactants and products except the pure form. So you see here 1 sodium, 1 oxygen, but 2 hydrogen atoms, 3 hydrogen atoms. Even number, odd number. In that case, I double number of atoms 2, number of 2 water molecules, 2 sodium hydroxide, right? And now 2 2s are 4 hydrogens, 2 2s are like 2 hydrogens here, 2 hydrogens. It is balanced chemical equation. Now from this we understand 2 atoms of sodium reacts with 2 molecules of water to produce 2 molecules of sodium hydroxide and 1 molecule of hydrogen. This is what we understand from this balanced chemical equation. Now the thing is, how can we make this chemical equation more informative, right? For that, we can add a few things. The things is, the first, number one is expressing physical state. Expressing physical state of reactants and products. Now we just look at this above equation. In this equation we could see sodium, water, sodium hydroxide and hydrogen. But how about their physical states? We do not know the physical states, right? This equation is not representing the physical states of reactants and products. So here we can add the physical states of reactants and products to the chemical equation. So that what I do is we take the balanced equation again, right? 2 sodium atoms reacting with 2 water molecules gives rise to 2 sodium hydroxide plus 1 hydrogen molecule. And here how can we make this more informative? Let's write what is this sodium? Sodium is a metal. We know except mercury, all other metals are solids at room temperature. So here this is sodium, which is solid at room temperature. So for representing this solid, I'm writing S in the bracket. This S represent this substance is solid, and water physical state at room temperature is liquid. And here sodium is reacting with solid sodium is reacting with liquid water to produce a solution of sodium hydroxide. So solution, I'm writing AQ representing aqueous solution. And what's the physical state of hydrogen? It is gas. So I write G. And this representing, S represents here, S in the bracket represent the given substance is solid. L in the bracket represent the substance is liquid. G in the bracket represent the given substance is gas. But how about this AQ? AQ is a solution. Okay, or it's more significantly we write more clearly we can write AQ representing its aqueous solution. It's aqueous solution, and this aqueous solution is represented by writing AQ in the bracket. Now looking at this equation, we understand solid sodium reacting with liquid water producing a solution of sodium hydroxide and a gas hydrogen is released. This is one way making this chemical equation more informative by expressing their physical changes, physical states. Okay, now let us see other extra information we can add it to it. Next, number 2 is we can add, okay, expressing heat changes, during a chemical change, during a chemical reaction. Let us see example here. Example number 1, let's write burning of any fuel. Let's take here burning of example number 1. Let me take burning of propane. Which burning of propane? What is propane? It is one of the components of LPG. So burning of propane, when propane is burnt, propane chemical formula is C3H8. Okay, let's write burning of propane. C3H8 when reacts with oxygen produces CO2 plus H2O. How can we balance it? 3 atoms of carbon left hand side, so right hand side we make it 3 atoms, so I write 3 here, 3 molecules of CO2, then 8 hydrogens, 4 hydrogens, 4 plus 6, 10, so I'm writing 5 here. This is a balanced equation. Okay, we can write what this physical states. Propane, what is propane? Is a gas. It is one of the component gases of LPG. I write G. Oxygen is also a gas. Carbon dioxide is also a gas. Here water vapor is also gas because it releases in the form of water vapor. So water vapor it is a gaseous state of water. So water vapor, so gas. I'm expressing physical states, and next expressing heat changes. So our main intention of burning gas is LPG is to get a heat energy, using that heat energy to cook food items. So here whenever this propane is burnt, it produces CO2, H2O, but the main intention of burning this LPG here to get heat energy. So this chemical reaction, in this chemical reaction, a lot of heat energy also is released. So I'm writing heat product side. This is before reaction, this is after reaction. As a result of chemical reaction, heat energy is released. So I'm writing heat product side. Okay, this can be represented like this, right? C3H8, I'll write C3H8 propane reacts with 5 molecules of oxygen, produce 3 molecules of carbon dioxide and gives 4 molecules of water plus heat. Heat energy is generally represented by Q. Q is not a product. Product should be a substance. But here Q, heat is not a substance, not a matter, it's a form of energy. So that energy, heat energy is represented by Q. So such chemical reactions in which heat energy is given out are generally called exothermic reactions. Right? Now, looking at this Q product side, if I write Q product side, heat energy is released along with the products, and we understand this type of chemical reactions are exothermic reactions. Okay, so Q is written like same way. Let me take another example for this exothermic reaction is when carbon is burnt. Carbon exists in different forms. When carbon is burnt, it reacts with oxygen, produces CO2 gas, and also it releases heat energy, This heat energy is represented by Q. So we can write it, right? Instead of heat, we just write Q, and that Q representing heat energy, and it is a exothermic reaction. And then let us see, this is one type. Okay, what is it? Exothermic reactions. Now let us see the second type. Okay, heat changes. Sometimes heat is also not always giving out, heat is also taken, it is absorbed by the substances. For example, let me take nitrogen gas reacting with oxygen gas, producing nitric oxide. What is this name? Its name is nitric oxide. When nitrogen combines with oxygen, it produces nitric oxide during this. Okay, if you generally take nitrogen, liquid nitrogen in one beaker, liquid oxygen in another beaker, if you mix both of them here, we get a nitric oxide, and this nitric oxide, if you touch, generally we feel cool. If you touch this, we feel so cool. When you touch the beaker, if it is beaker, I'm holding the beaker, then I feel very cool, because this content, this nitric oxide, during the formation, it takes heat energy from our body, so we feel cool. And here in this reaction, heat energy is absorbed. And such reactions are called what? Endothermic reactions. They are called endothermic reactions. How do we understand from chemical equation that the given one is endothermic reaction? Simply, in exothermic reaction, we have written plus Q like this, and for endothermic reactions, what do? We simply write product side minus Q. If minus Q is written product side, and that is a endothermic reaction. If plus Q is written product side, that is a exothermic reaction. In endothermic reactions, heat energy is absorbed. Whereas in exothermic reactions, heat is released. It is released, given out. Okay, and this endothermic reaction, right, equation, we can also add it N2 plus O2, right, plus heat energy gives rise to 2NO. This is also, if you write plus Q reactant side, that is also representing endothermic reaction. If I write plus Q product side, that is exothermic reaction. If I write plus Q reactant side, that is a endothermic reaction. This is the second information we get from the balanced chemical equation. What is it? First one is writing a physical state. So I'm taking liquid nitrogen, liquid oxygen, I get nitric oxide. Okay, so here what happens, Nana? Heat energy is absorbed, so it's a endothermic reaction. This is another way of writing more information, giving more information from to a balanced chemical equation. First writing physical state, second expressing the heat changes happening during the chemical reaction. Okay, now let's see third one. So third one is expressing precipitates formed during a chemical reaction. Let me take an example here. If I take a sodium chloride solution, we understand sodium chloride solution. This is added to silver nitrate solution, AgNO3 solution, silver nitrate solution. When these two solutions are mixed with each other, it produces sodium nitrate solution. These three solutions are colorless. This is also a colorless solution. This is also a colorless solution. The three are colorless solutions. Along with this colorless solution, we get an insoluble substance, that is AgCl. So I am writing here AgCl is insoluble substance. Okay, the color is white color. Okay, insoluble substance. Such insoluble substances formed during a chemical reaction are generally called precipitates. They are generally called precipitates, and these precipitates are represented in two ways. One way, writing PPT in the brackets, or we can also write a downward arrow representing a precipitate. So here, since AgCl is a precipitate here, I write a downward arrow here. Okay, this is one way, or else we can write here AgCl formed, okay, as PPT, representing this is an insoluble substance formed during this chemical reaction. Okay, so expressing the precipitates formed, precipitates are formed with the downward arrow. Because why downward arrow? Most of the times when I write a downward arrow, like it's representing precipitate, because in a chemical reaction, the precipitates formed, insoluble substances formed, generally they deposited at the bottom of the container. So the direction of the deposition is represented by downward arrow. That also indicates the precipitate formed here. And opposite to this, whenever a gases are formed, for example, in the previous case, hydrogen is formed. Instead of writing G representing gas, we can also write a hydrogen H2. Just beside it, we can write upward arrow because gases tends to escape. So we write an upward arrow representing gases. So I'll write here the upward arrow represent gases, downward arrow represents precipitates. They represent precipitates. This is a third way, like third information, extra information we can add it, right? First one is physical state, second one heat changes, third one precipitates formed during a chemical reaction. See, unlike otherwise, if I don't write this arrow mark here, if I don't write insoluble substance here, we cannot understand whether the AgCl is solution, is it a liquid, is it a solid, we cannot understand. If you know AQ, NaCl solution, AgNO3 solution, NaNO3 solution. If without writing anything here, we can't understand the nature, physical state of AgCl. If I can write a downward arrow, then we understand the substance formed is a precipitate, right? This is a third one. Now let us see one more. There is another information can be added to a balanced chemical equation. So what is that? We'll see. So it is the fourth one. What is it? Expressing conditions required. So next one is expressing conditions required for the chemical reaction. So what are the conditions required? Generally, the conditions can be temperature, pressure, or need of sunlight, or using a catalyst, etc. Okay, these are the conditions required for the chemical equation, right? Then let's see an example. We'll see an example. Let me write a preparation of ammonia. Let me take example, preparation of ammonia. This is one of the important commercial products, substances ammonia, which is used to make fertilizers, right? Then for preparation of ammonia, generally this ammonia is prepared by a method called Haber's process. In this process, ammonia is prepared from nitrogen and hydrogen, right? Nitrogen and hydrogen react with each other to produce ammonia NH3. Here nitrogen is a gas, hydrogen is a gas, ammonia that produced is also gas. Now shall we balance it? We have 2 nitrogens left hand side. I'll write 2 NH3, 2 nitrogens, 2 3s are 6. Then I write 3 here, 3 2s are 6 hydrogen atoms. This is a balanced chemical equation and the physical states are also mentioned here. But what else is needed here? Okay, in this reaction, what are the conditions required? See, under normal conditions, this reaction is very slow. It is very slow under normal conditions. It is very slow reaction. Okay, to produce excess of ammonia, it takes very long period industrially. Okay, so to increase the rate of this reaction, what happens generally, some conditions are required. Under normal conditions, it is very slow, but under specific conditions, special conditions, this rate of reaction can be increased. What are those conditions? The conditions are generally temperature, pressure, and also a catalyst used. Let's say in this process, this is generally happens at a 500 degrees Celsius. The temperature, if the temperature is 500 degrees Celsius, normal temperature is 27 degrees Celsius, room temperature, but under extreme conditions like 500 degrees Celsius temperature, very high temperature, and this reaction in the presence of also, what do we say, the pressure is generally 200 to 400 atmosphere pressure. The normal pressure is only 1 atmosphere. But what's the pressure used here? 200 to 400 atmosphere. Like normal, than a normal pressure, the pressure that we used is 200 to 400 times is more. So under these conditions, 500 degrees Celsius, 200 to 400 atmosphere pressure, and the presence of a mixture called iron and molybdenum. iron and molybdenum mixture. Fe representing iron and MO representing molybdenum. So the mixture of iron and molybdenum, what is this? This mixture act like a catalyst. This catalyst doesn't participate in the chemical reaction, it doesn't undergo any change, but what it does, it alters the rate of the reaction. That means mostly it increases the rate of reaction, so the reaction happens faster than a usual time. When iron molybdenum is of mixture is used, iron is one metal, molybdenum is also a metal, and their mixture here increases the production of increases speed of the production of ammonia gas under this condition. These are the conditions required. So now as you see this equation, whenever a chemical equation is written, the conditions required for the chemical reaction are just written above or below the arrow mark. If any conditions are written above or below, and we understand that they are necessary for carrying out this specific chemical equation. Let us see one more example. Example number 2, very familiar example, right? Preparation of food by plants using the process called photosynthesis. So for that we know CO2 reacts with H2O, produces glucose C6H12O6 plus oxygen gas is released. Okay, this we can balance 6 molecules of carbon dioxide, 6 molecules of water, 6 molecules of oxygen. It is balanced, right? Carbon dioxide is a gas, water is a liquid, glucose is a solid, oxygen is a gas. Glucose is a solid and oxygen is a gas. And for this we all know, okay, for carrying out photosynthesis, plants need two things. One is green plants can prepare food. Green plants, the green color substance is chlorophyll. Chlorophyll is important. And also at night time can plants prepare food? No, they need sunlight. So sunlight and chlorophyll, they are required by the plant. They are compulsory conditions to carry out the photosynthesis. So we write the conditions required here. I write sunlight. For writing conditions, I am using the space above and below the arrow mark. Sunlight is required, and what else required on it? We also required chlorophyll. It also required chlorophyll. So in this case, sunlight and chlorophyll are the conditions required for this chemical change. In the earlier case, the temperature and pressure and also a catalyst are required for carrying this photosynthesis. So here I would like to give you what is the meaning of catalyst. It is very important for board exams, right? Let me write catalyst. What is catalyst? Okay, catalyst is the substance that alters means changes, alters the rate of reaction. Rate of reaction means the speed of reaction, alters the rate of reaction but doesn't undergo any change. Such substances are generally called a catalyst. So here the mixture of iron and molybdenum is an example of catalyst. Okay, and here in photosynthesis they are not catalysts, they are not substances required here. They are not promote the rate of reaction. Iron molybdenum increases the speed of reaction, but sunlight and chlorophyll are required. In the absence of these conditions, this reaction doesn't takes place. Okay, this is another way expressing conditions required for a chemical reaction. So okay, these are the 4 ways we make chemical equation more informative, okay, by adding different things. The first thing is adding their physical states, solid, liquid, gas or aqua solution. Second is expressing the heat changes. If it is exothermic, we write plus Q product side. If it is endothermic, we write minus Q product side or plus Q reactant side. The third one, precipitates formed, we use downward arrow for precipitates and upward arrow for gases. And lastly, writing the conditions required using the space above and below the arrow mark. Okay, in these 4 ways we can make a chemical equation more informative.